In 2006, we erased it from the solar system, not with a weapon, not with a collision, with a vote. A handful of astronomers in a conference room in Prague raised their hands, and just like that, a world that had orbited our sun for 4.5 billion years was stripped of its title, demoted, diminished, and discarded. We called it a dwarf, a piece of dead, floating debris lost in the freezing dark at the edge of everything. But when we finally sent a camera, a single fragile spacecraft, 4 billion miles into the abyss, what we found terrified us. We thought we would see a quiet, frozen rock, a dead, featureless sphere drifting silently through the void, unremarkable and forgotten. Instead, we found a world that was alive in ways we never imagined, a world with floating mountains of water ice as hard as steel, skies that bleed red snow, a giant pale heart made of churning, boiling toxic nitrogen that consumes everything it touches, and beneath its frozen crust, an ocean of liquid water hiding in the darkest, coldest place in our solar system, billions of miles from the nearest star. For 76 years, we called it a planet. Then, we threw it away. But the exiled king of the solar system is not dead. It never was. It is a beautiful, freezing nightmare, a world of impossible contradictions, breathtaking and lethal in equal measure. It is a place that would destroy a human being in ways both spectacular and horrifying. And it is a place that raises one of the deepest questions in all of science. This is the true story of Pluto. Imagine traveling into the abyss for almost a decade. Not a day, not a month, 9 years. 4,600,000,000 miles of empty, freezing vacuum, hurtling through the dark at 50,000 miles per hour, faster than any bullet ever fired, faster than almost anything humanity has ever built. That is what it took for the New Horizons spacecraft to reach Pluto. Launched in January 2006, the very same year Pluto was stripped of its planetary status, it crossed the orbit of Mars in just 9 hours. It passed Jupiter in 13 months, using the gas giant's gravity like a slingshot to add another 9,000 miles per hour to its already blistering speed. And then it kept going, and going, through the asteroid belt, past Saturn, past Uranus, past Neptune, deeper into the cold and the dark than any spacecraft in history had traveled with a specific destination in mind. As you push further away from Earth, the sun slowly begins to shrink. At first, the change is barely noticeable, but by the time you pass Mars, the sun is already noticeably smaller than the blinding disk we know from home. By Jupiter, it is merely very bright, still dominant, still the undisputed master of the sky. But by the time you reach Neptune's orbit, something fundamental has changed. The sun is no longer a disk. It is a point, an intensely bright point, brighter than any star in our sky by far, but a point nonetheless, reduced, diminished, its warmth and light attenuated by distance into something cold and distant and insufficient. And by the time you reach Pluto, the sunlight is hundreds of times dimmer than a cloudy afternoon on Earth. Not a dramatic overcast gray, a cloudy afternoon. Pluto receives so little solar energy that if you transplanted Earth's surface there, every ocean would freeze solid within years. Solar panels, our go-to power source for space missions, are essentially useless at Pluto's distance. That is why New Horizons ran on nuclear power, a radioisotope thermoelectric generator converting the heat of radioactive decay into electricity because the sun itself was too far away to rely upon. If you were standing on Pluto's surface at noon, solar noon, the moment when the sun is at its highest in the sky, you would not need sunglasses. You would not see a bright blue sky. You would see something that looks more like the sky 30 minutes after sunset on Earth. A deep, cold twilight. The sun would be a tiny, searingly bright point, too small to see as a disk with the naked eye, casting long, pale shadows across the icy landscape. The sky around it would not be blue. It would be black. A permanent, freezing twilight stretching in every direction, an eternal reminder that you are very, very far from home. The temperature? Minus 390 degrees Fahrenheit, minus 234 degrees Celsius, cold enough to freeze air itself, not just water, not just carbon dioxide, but the nitrogen that makes up 78% of Earth's atmosphere would be solid ground beneath your feet on Pluto. New Horizons made its closest approach on July 14, 2015, after 9.5 years of travel. It had only a few hours to observe Pluto at close range before its trajectory carried it onward, deeper into the Kuiper Belt. There were no second chances, no do-overs. Every instrument had to work perfectly. Every command had to be pre-programmed months in advance. And in those few hours, everything we thought we knew about Pluto was shattered. In the summer of 2015, our cameras finally pierced the veil. The first clear images came through slowly, pixel by pixel, transmitted across 4.5 billion miles of empty space at the speed of light, and still taking over 4 hours to arrive. Scientists and engineers crowded around screens in the Mission Control Room at Johns Hopkins University Applied Physics Laboratory. And then, there it was. Right there, across the equator of this distant world, was a heart. A giant, perfectly shaped heart. A pale white-pink anomaly shining against the mottled reddish-brown surface of Pluto like a beacon, like a message, like something impossibly deliberate and beautiful. The media called it cute. A cosmic Valentine, the universe sending a signal of love from the edge of the solar system. But planetary scientists knew the truth. That heart is not a symbol of love. It is a scar, a massive impact basin, a crater formed billions of years ago when something enormous smashed into Pluto's surface and carved out a depression nearly 1,000 kilometers wide. To put that in perspective, that is roughly the distance from New York City to Chicago, an impact so colossal it reshaped the entire planet. Scientists named it Sputnik Planitia in honor of the first artificial satellite, and what fills it is not rock or ordinary ice. It is a colossal glacier made entirely of solid nitrogen, methane, and carbon monoxide, 3 of the most toxic substances found in nature. On Earth, liquid nitrogen is used to freeze and destroy tissue. It is kept in specialized containers and handled with extreme care. On Pluto, it covers an area the size of Texas and Oklahoma combined, sitting thousands of feet deep, shining with an eerie pale light. But here is the most shocking part. This glacier is not dead. Deep beneath Pluto's frozen surface, the core still holds a tiny, precious amount of radioactive heat, the lingering warmth of uranium and thorium decaying slowly over billions of years. On Earth, this geothermal heat powers volcanoes and drives tectonic plates. On Pluto, it is almost nothing, a whisper, a ghost of warmth in an otherwise dead world. But even that ghost is enough. This faint warmth rises up through the ice, reaching the base of the nitrogen glacier, and nitrogen, unlike water ice, has an extremely low melting point even at very high pressures. The heat causes the very bottom layer of the glacier to slowly, almost imperceptibly, melt and then refreeze in a process called convection, the same process that drives weather patterns in Earth's atmosphere and currents in Earth's mantle. The frozen nitrogen slowly boils and churns like a pot of impossibly thick, impossibly cold soup. Giant convection cells hundreds of kilometers wide slowly turn over and over, bringing material from the deep up to the surface and then dragging it back down. The result is extraordinary and deeply unsettling. This constant churning means the surface of Sputnik Planitia is perpetually new. Any asteroid crater that forms here, any space rock that crashes into this toxic ocean, is slowly, relentlessly consumed. The impact site is pulled downward by the circulation, swallowed into the depths, and erased. The surface remains pristine, white, perfect. It is a sea that consumes its own wounds, that heals itself endlessly, that leaves no scar. It is a pristine white sea that consumes everything it touches. The rate of this erasure is staggering. Scientists estimate that the surface of Sputnik Planitia is completely renewed every few 100,000 years, almost instantaneous on geological timescales, while the rest of Pluto bears the pockmarked scars of billions of years of asteroid impacts. The heart remains perfect, untouched, as if the universe specifically carved out this one pristine space at the edge of everything and decided to keep it clean. Why is the heart shaped like a heart? The exact bilateral symmetry is almost certainly coincidental, a lucky alignment of the impact basin's shape and Pluto's rotation. But the reason it sits on the equator is not coincidental at all. The enormous mass of the nitrogen glacier, far heavier than the surrounding terrain, creates a gravitational anomaly. Over millions of years, this anomaly caused Pluto to slowly roll over, rotating until the heavy heart settled at the lowest gravitational potential energy position, facing directly away from Charon. It is as if Pluto reorganized its own body around the weight of its beating heart. The true extreme nature of Pluto lies not at the center of that toxic heart, but at its edges. If you could stand on the shores of Sputnik Planitia, and you could not, because you would be dead before you got there, but imagine it. You would see something that no human artist could have dreamed up. Rising from the edge of the white plain, towering thousands of feet into the pitch-black sky, are mountains. Not hills, not ridges. Mountains. Jagged, brutal, knife-edged peaks, standing over 10,000 feet tall, comparable to the Rocky Mountains, comparable to the Alps, rising from the flattest, most pristine plain in the solar system, like teeth from a jaw. On Earth, mountains are made of rock, silicate rock, granite, limestone, basalt, stone that was forged in volcanic fires billions of years ago and shaped by the slow grind of tectonics. On Pluto, rock is essentially irrelevant. At minus 390 degrees Fahrenheit, ordinary water ice, the stuff of glaciers and ice rinks and frozen lakes, is not soft. It is not slippery. It does not flow or deform under pressure. At these temperatures, water ice becomes as hard as granite. Harder even. It becomes a structural material comparable to steel in its ability to support enormous loads without deforming. Those mountains are made entirely of water ice. Billions of years of accumulated ice, compressed and refrozen over and over until it has the mechanical properties of rock. Razor-sharp peaks, carved not by wind or rain. There is no significant rain on Pluto, but by the slow thermal stress of a world that cycles between barely frozen and impossibly frozen as it makes its 248-year orbit around the sun. And here is where it gets deeply strange. Water ice is less dense than liquid nitrogen, not by a small margin, by a significant one, which means that these massive mountain ranges, these 10,000-foot peaks of solid water ice, do not sit firmly on the ground like normal mountains. They float, literally float. Like icebergs in an Arctic Ocean, but scaled to mountain ranges, these peaks break off from the surrounding terrain and drift slowly across the surface of the nitrogen glacier. Imagine the Alps. Now imagine the Alps slowly detaching from their foundations and drifting across a white plain of frozen poison, moving at perhaps a few centimeters per year, imperceptible on human timescales, but over millions of years, covering enormous distances. Mountain ranges that travel. Mountain ranges that are, in the strictest physical sense, giant icebergs. Scientists have named some of these floating ranges. Hillary Montes and Tenzing Montes, named for Edmund Hillary and Tenzing Norgay, the first climbers to summit Everest. A deeply poetic choice, naming Pluto's mountains after the men who conquered Earth's highest peak. These mountains rise as high as 3,500 meters above the surrounding plain. They are not small. They are not minor geological features. They are genuine mountain ranges drifting slowly across a toxic sea. And if you look closely, if you could zoom in on those peaks against the black sky, you would notice something deeply unsettling about the snow that caps them. It is not white. It is dark red. The mountains are bleeding when the faint ultraviolet light from the distant sun, weak, attenuated, but still present, hits the frozen methane on Pluto's surface. It triggers a slow, quiet chemical reaction. The UV radiation breaks apart methane molecules, freeing carbon and hydrogen atoms that recombine into complex organic compounds. Scientists call these compounds tholins, from the Greek word for muddy, because they tend to form a reddish-brown sludge. Tholins are found throughout the outer solar system. They paint the surface of Saturn's moon Titan. They redden the nuclei of comets. And on Pluto, they drift down from the atmosphere like a slow, eternal dark red snow, coating everything they touch in a layer of organic rust. The peaks of the mountains elevated above the surrounding terrain catch the most of this red rain. They accumulate it. They turn dark. The highest points on Pluto's surface, the points closest to the sky, are stained the color of dried blood. A freezing world covered in mountains of floating water ice, capped with organic rust the color of old wounds, rising from a sea of solid poison. This is what a beautiful nightmare looks like. For decades, we assumed Pluto was simple, just a solid frozen rock all the way from surface to core, with no internal complexity, no liquid water, no geological surprises, just a ball of ice and stone, frozen solid and dead. The physics broke that assumption. Here is the problem. The heart, Sputnik Planitia, is enormous. A basin nearly 1,000 kilometers wide, filled with kilometers-deep nitrogen ice, sitting on the equator of a world with an oblate shape. The sheer weight of this massive glacier creates a gravitational anomaly, a region of slightly stronger gravity on that side of Pluto. And gravitational anomalies on rotating bodies cause those bodies to roll over time, a process called true polar wander. The numbers don't add up unless there is something heavy on the opposite side of the planet, acting as a counterweight, something dense enough to balance the mass of a glacier the size of Texas, something that could not be solid ice alone. The only thing that makes physical sense, the only solution that satisfies the equations, is a subsurface ocean. A massive layer of liquid water hiding beneath Pluto's frozen crust, kept from freezing by the pressure of the ice above it and the faint geothermal heat from below. Scientists now estimate this ocean may be 100 kilometers deep, deeper than Earth's deepest ocean by an enormous margin. Let that sink in for a moment. At the furthest edge of the solar system, nearly 4.7 billion miles from the Sun, in a world that orbits in permanent frozen twilight, at minus 390 degrees Fahrenheit, there may be a vast, dark, liquid ocean. Not frozen, not ice, liquid water. And wherever there is liquid water, the ultimate question arises. Could something be swimming in the dark? This is not idle speculation. Earth's deep oceans harbor entire ecosystems that survive without any sunlight at all, feeding instead on chemical energy from hydrothermal vents, from the slow decomposition of organic material from each other. Life in Earth's deepest, darkest, most inhospitable environments is not the exception. It is disturbingly common. We keep finding life in places where life should not exist, which has forced us to fundamentally reconsider what habitable actually means. Pluto's subsurface ocean would be cold, dark, under enormous pressure, isolated from the surface by kilometers of solid ice. But by the standards of Earth's extremophiles, those conditions are not necessarily deal breakers. We have found bacteria surviving in Antarctic ice sheets, kilometers deep. We have found organisms living in boiling, acidic volcanic vents. We have found life in the Atacama Desert, arguably the driest place on Earth, surviving on trace moisture that condenses on rocks at night. Could something live in Pluto's dark ocean? We don't know. We simply do not know. And that uncertainty, that possibility, transforms Pluto from a dead rock at the edge of nowhere into something far more profound. A potential cradle of life. A world that might harbor biology so alien, so different from anything we have ever imagined, that it would challenge every assumption we have about what life means. The New Horizons mission could not answer this question. It flew past Pluto at 50,000 miles per hour and kept going. There is no orbiter, no lander, no probe drilling through the ice to sample the ocean below. The question remains open, hanging in the dark, unanswered. And perhaps that is appropriate. Some mysteries should remain mysteries for a while. They keep us looking up. As our spacecraft sped away into the deeper Kuiper Belt, its mission at Pluto essentially complete, mission controllers sent one final command. Turn around, look back, take one last photograph. And in that photograph, transmitted back to Earth over the course of hours, each pixel a small miracle of physics and engineering, we saw something nobody expected. Pluto has a blue sky, not a permanent blue sky, not a bright, thick atmosphere like Earth's, but in the image of Pluto eclipsing the sun, with the spacecraft looking back at the dark silhouette of the planet against the distant light, there was a delicate, glowing ring of blue. A haze layer, backlit by the sun, scattering light in just such a way as to glow with a soft, heartbreaking blue. The same physics that makes Earth's sky blue, Rayleigh scattering, the preferential scattering of shorter wavelengths of light, was happening on Pluto. in an atmosphere 100,000 times thinner than ours at the edge of the solar system. It was a breathtaking moment of beauty, a reminder that Pluto, for all its hostility, for all its cold and darkness and poison, is not simply a rock. It is a world, a complex, layered, astonishing world that had been playing its own slow games long before the first living cell appeared on Earth, and would continue playing them long after the last one dies. Pluto's atmosphere is itself a wonder of strangeness. It is made primarily of nitrogen, like Earth's, with traces of methane and carbon monoxide. But unlike Earth's atmosphere, Pluto's is seasonal in the most extreme way imaginable. When Pluto swings to its closest point to the Sun, still vastly farther than Neptune, the surface warms slightly, and the frozen nitrogen on the surface sublimates, turns directly from solid to gas, expanding the atmosphere. When Pluto retreats to its furthest point from the Sun, the atmosphere collapses back to the surface, freezing out entirely, snow falling from a sky that can no longer hold it. The atmospheric pressure at Pluto's surface is roughly 10 microbars, about 100,000 times less than Earth's sea level pressure. You would not be able to breathe it even if it were pure oxygen. It is essentially a hard vacuum with decorative gas, but that thin atmosphere does something remarkable. It creates weather, not weather like Earth's, not weather you could survive, but genuine atmospheric dynamics, winds, hazes, temperature inversions, even what appeared to be clouds in some of the New Horizons images. A world this small, this cold, this far from the Sun should have no right to weather. And yet, Pluto does not endure this bizarre existence alone. Locked in a permanent gravitational dance with Pluto is its largest moon, Charon. And Charon is not merely a moon in the conventional sense. It is, by almost any reasonable measure, a coplanet. Charon is so large relative to Pluto, about half its diameter, about 1/8 its mass, that the gravitational center of their orbit, the barycenter, does not lie inside Pluto at all. It lies in empty space between them. This is a binary system, two worlds orbiting a point of nothingness together, locked in an eternal dance. They orbit each other every 6.4 Earth days. And because they are tidally locked, each always showing the same face to the other, Charon is permanently frozen in Pluto's sky. If you stand on the side of Pluto that faces Charon, it hangs there, massive and unmoving, a gray world roughly the apparent size of an orange held at arm's length, much larger than our moon appears from Earth. It never rises. It never sets. It just watches. If you walk to the other side of Pluto, you will never see Charon at all, ever. It is permanently hidden, a world that exists and yet cannot be seen from half the planet's surface. The Charon-facing side of Pluto and the anti-Charon side experience fundamentally different skies, different tidal forces, different geological histories. Charon itself is a tortured world. Its north pole is stained with a massive, dark, red-brown spot, the Mordor Macula, named for the Dark Realm in Tolkien's Legendarium, and the name is apt. This dark polar stain is not local geology. It is gas that escaped from Pluto's atmosphere, methane primarily, that drifted across the 20,000-kilometer gap between the two worlds, reached Charon, and was trapped by Charon's frigid polar temperatures. It froze there, exposed to radiation, converted by UV light into tholins over billions of years, and stained Charon's pole the color of rust and shadow. They are two cosmic outcasts sharing the same bleeding atmosphere. Pluto breathes out, and Charon drinks in that breath, freezing it onto its own skin. They are connected not just by gravity, but by chemistry, by atmosphere, by the slow exchange of molecules across millions of years. They are not just a planet and a moon. They are a system, a partnership, two worlds that have shaped each other over billions of years. And then there are the small moons, Nix, Hydra, Kerberos, and Styx, four tiny worlds irregularly shaped, tumbling through the dark in orbits that are, to put it bluntly, chaotic. Their rotations are not tidally locked. They spin unpredictably, tumbling like fragments of something catastrophic, which is exactly what they are. The current scientific consensus is that all of Pluto's moons were created in a single, ancient collision, similar to the impact that created Earth's moon. Something enormous smashed into Pluto billions of years ago, and the debris from that collision, the material thrown out into orbit, eventually coalesced into Charon and the 4 small moons. These 4 small moons tumble in ways that are genuinely chaotic, meaning their rotation states are not predictable over long timescales. If you stood on Nix and looked up, the sky above you would behave strangely. The sun would rise and set at irregular intervals. Charon and Pluto would arc across the sky on paths that vary over time. Nothing would feel fixed. Nothing would feel reliable. It would be a sky of permanent uncertainty. Let us now be honest about what Pluto would do to a human body. Not in vague terms, in specific, thorough, unsparing detail. You would not arrive in good shape. Even if you somehow solved the 9-year travel problem, which we have not for human beings, the journey itself would be devastating. 6 months in microgravity, as we have learned from the International Space Station, causes measurable bone density loss, muscle atrophy, cardiovascular deconditioning, vision problems from intracranial pressure, and immune system dysregulation. 9 years in microgravity, even with exercise and countermeasures, would leave a human being in a state of profound physiological deterioration. But let's say you arrived, somehow, in good health. What then? At minus 390 degrees Fahrenheit, minus 234 Celsius, the thermal challenge on Pluto is unlike anything faced by human missions so far. The coldest inhabited place on Earth is the Russian Vostok station in Antarctica, which has recorded temperatures down to minus 89 degrees Celsius, brutal life-threatening cold. Pluto is nearly 3 times colder than that, 3 times colder than the coldest place any human being has ever survived. The insulation challenge alone is extraordinary. A spacesuit sufficient to keep a human alive on the moon, designed for the roughly minus 173 degrees Celsius of lunar night, would be completely inadequate. The engineering required to maintain a livable internal temperature while managing the thermal differential between 37 degrees Celsius inside the suit and minus 234 degrees Celsius outside, it would require heating systems of extraordinary power and reliability, drawing on energy supplies that would themselves be difficult to obtain, given the uselessness of solar panels at Pluto's distance. Any mechanical failure, any crack in insulation, any failure of a heating element would be immediately, catastrophically fatal. You would not have time to diagnose the problem and apply a fix. At those temperatures, exposed skin would freeze in seconds. Liquid in your tissues, in your eyes, in your lungs, at the edges of your body would freeze before any rescue was possible. Pluto's gravity is approximately 6.3% of Earth's. If you weigh 180 pounds on Earth, you weigh about 11 pounds on Pluto. This sounds wonderful. It is not. The human body is exquisitely tuned to Earth's gravitational environment. Our hearts pump blood upward against gravity. Our vestibular systems orient us using gravity as a reference. Our bones maintain density because gravity constantly loads them. Our proprioception, our sense of where the body is in space, is calibrated to 1G. In 6.3% gravity, all of this breaks. Blood pressure regulation fails. Fluid shifts toward the upper body and head. Bones, no longer loaded by body weight, begin to demineralize at rates comparable to severe osteoporosis. Muscles atrophy because the loads they're designed to handle don't exist. After years on Pluto, returning to Earth would be not just difficult, but potentially fatal. The return to full gravity might shatter bones weakened by years of disuse. Mars at 38% gravity is considered a major physiological challenge by space medicine researchers. Pluto's gravity is 6 times less than Mars's. We have essentially no data on what that does to the human body over the long term. Earth is protected from space radiation by its magnetic field and thick atmosphere. Pluto has neither. Without these protections, the surface is exposed to the full spectrum of cosmic radiation, galactic cosmic rays, solar energetic particles, and deep space background radiation. The annual radiation dose on Pluto's surface is estimated at several hundred millisieverts per year, many times the occupational dose limit for radiation workers on Earth. Over a multi-year mission, the cumulative dose would significantly increase cancer risk, cause cataracts, and damage the cardiovascular system. During a major solar energetic particle event, the additional acute dose could be immediately dangerous. Unlike on the ISS, where astronauts can shelter in shielded sections during solar storms, a Pluto habitat would need substantial shielding built into its structure from the start, adding mass and complexity to an already impossibly difficult engineering challenge. When Apollo astronauts were on the moon, communications with Houston were delayed by 1.3 seconds. Annoying, but manageable. On Mars, the delay ranges from 3 to 22 minutes, already deeply significant for emergencies. Emergency procedures on Mars must, by necessity, be fully autonomous. At Pluto's distance, one-way communication delay is approximately 4.5 hours. A round trip takes 9 hours. If something goes catastrophically wrong, a suit breach, a habitat failure, a medical emergency, the crew is entirely alone. There is no mission control to consult. Whatever happens, they handle it themselves, or they die. The psychological weight of that isolation is difficult to overstate. Every decision made on Pluto is made in absolute self-reliance. There is no safety net. You are, in every meaningful sense, alone. On Earth, humans require water, air, food, and warmth, all of which exist in abundance. In space, all must be manufactured and maintained. The ISS receives regular resupply missions from Earth. Pluto cannot be resupplied. Any mission there must be entirely self-sufficient for its entire duration, potentially decades. Every calorie of food, every breath of air, every drop of water must be carried from Earth or produced on site. The energy required to maintain life support at minus 234 degrees Celsius would be enormous, drawing on nuclear systems that require maintenance and cannot be easily repaired. In the history of human exploration, we have never attempted anything approaching this level of isolation. Antarctic winter stations are isolated for months, not years, and can be reached by aircraft in an emergency. Submarine crews surface in known locations with rescue options nearby. The ISS is never more than a few hours from emergency evacuation. Pluto is a category apart, a one-way ticket in the most literal and terrifying sense. The human brain was not designed for this. It was designed over millions of years of evolution for a world of sensory richness, sunlight and shadow, the smell of soil and rain, the sounds of other living things, the constant low-level confirmation that you exist within a community, within a web of relationships, within a world that is alive and changing around you. Pluto offers none of this. The sky is black at noon. The sun is a bright point reduced to the status of a very bright star. The landscape is frozen and still, covered in reddish-brown dust and pale white ice. There is no weather as you would recognize it. There are no seasons you would live to see. Pluto's year is 248 Earth years. There are no living things, no wind audible through a habitat wall, no water sounds, no bird calls, no insect buzzing, no distant animal movement. Silence. Deep, profound geological silence, punctuated only by the mechanical hum of life support equipment. Research on sensory deprivation and isolation is not encouraging. Antarctic winter-over crews, isolated for months in conditions far less extreme than Pluto, report significantly elevated rates of depression, sleep disturbance, cognitive impairment, and interpersonal conflict. In a habitat on Pluto, these pressures would be amplified by the absolute knowledge that there is no rescue, no emergency evacuation, no possibility of being sent home early. The communication delay, 4.5 hours one way, means that real-time voice from home is not available. A conversation that takes 5 minutes on Earth takes 9 hours on Pluto. Communication becomes correspondence, messages in bottles, not lifelines. Autonomy stress. The anxiety of knowing every decision rests entirely on you, with no external safety net, would be a permanent condition. Every astronaut on a Pluto mission would face every day knowing that a mistake could be fatal and unreachable by any help within any relevant time frame. The Shackleton expedition to Antarctica in 1914-17 is the gold standard of human survival under extreme isolation. Shackleton and his crew endured 2 years of brutal conditions, and when they needed rescue, they could reach human civilization by sea in a matter of weeks. Pluto is the Shackleton expedition without any possibility of rescue, ever. At this point, the obvious question arises: why send humans at all? It is a fair question with a fair answer. For many purposes, you don't have to. New Horizons showed us more about Pluto in a single flyby than 76 years of telescopic observation had revealed. Robotic missions are cheaper, lighter, faster, more radiation tolerant, and they don't require food, air, or psychological support. A robotic lander on Pluto, a rover crawling across the nitrogen glacier, a drill probing toward the subsurface ocean, all technically conceivable in the coming decades. But robots have limits that become increasingly apparent the further we push exploration. Opportunity lasted 15 years on Mars, teaching us immense amounts about Martian geology, but it could not pick up an interesting rock and make the kind of intuitive judgment call that a geologist would make in seconds. Curiosity and perseverance, the most sophisticated rovers ever built, move at a few hundred meters per day. A human geologist covers the same ground in minutes. The 4.5-hour communication delay to Pluto makes real-time rover control impossible. Every command must be carefully pre-planned and uploaded in batch. The feedback loop is so slow it constrains everything: speed, adaptability, the capacity to pursue scientific hunches. A geologist who spots an interesting rock doesn't wait 9 hours to decide whether to examine it. AI autonomy can compensate for some of this. Ingenuity on Mars demonstrated impressive aerial autonomy. Future systems will be better, but there are questions that robots cannot easily answer. Questions requiring the full bandwidth of human sensory processing, adaptive scientific inquiry, the recognition of life signs that require interpretation rather than mere detection. The argument for human exploration of Pluto is not logistical, it is philosophical. We have always sent people to the places that matter most, not because robots couldn't have planted a flag on the moon, but because humans needed to stand there, to look back, to understand in their bones what it means to be a speck of biology in an incomprehensible universe. Whether we should do that at Pluto, given the cost and risk, is a genuine ethical question. But the argument that robots make it unnecessary misunderstands why humans explore at all. There is a recurring narrative in popular science communication that goes like this: Earth is fragile. Humanity needs a backup planet, another world where civilization can take root if Earth fails us. This argument has real weight. The danger of keeping all of humanity's eggs in one planetary basket is not trivial. But Pluto is not the answer. Sometimes, in the enthusiasm for all things space, Pluto gets mentioned in the same breath as Mars, Europa, and Titan as a potential future human home. It should not be. Not because Pluto is unimportant, but because the challenges of human habitation. There are not engineering problems awaiting solutions. They are fundamental conflicts with biology. Mars has 38% of Earth's gravity, a day almost exactly as long as Earth's, and a chemical toolkit, carbon dioxide, water ice, that can be converted to oxygen and water through known chemistry. It is not comfortable, not easy, but functionally survivable on a semi-permanent basis. Terraforming Mars is a multi-century project, but at least conceptually within thermodynamic reach. Pluto's gravity is 6% of Earth's. Its year is 248 Earth years. Its temperature is minus 234 Celsius. The Sun provides 1/1600th the energy per square meter that it delivers at Earth's orbit. You cannot terraform Pluto, not in any practical time frame, not without energy sources that do not exist. The only way to survive on Pluto long-term would be in entirely sealed, artificial environments, large space stations sitting on a very cold surface, maintaining every life requirement through systems of extraordinary complexity, operating without any possibility of outside assistance for years at a time. That is not a backup civilization. That is a monument to deliberate self-endangerment. Not every world needs to be a human home. Some worlds can simply be worlds, remarkable, strange, beautiful, scientifically invaluable. Pluto's value to humanity is not as real estate. It is as a mirror, as a question, as a reminder of how vast and varied and alien the universe is, even within the modest confines of our own solar system. We took something from Pluto in 2006, a name, a title, a category. We reduced it, linguistically and formally, from a planet to a dwarf, a demotion that still generates heated debate, not just among the public, but among professional astronomers who believe the International Astronomical Union's definition of planethood is scientifically inadequate. But Pluto did not notice. It continues its slow, elliptical orbit around the Sun, an orbit so eccentric that it sometimes passes inside the orbit of Neptune, the official 8th planet. It continues the slow convection of its nitrogen glacier, erasing the scars of ancient impacts, keeping its surface pristine. It continues exchanging atmosphere with Charon, painting its moon's pole with the rust of shared chemistry. Its 4 small moons continue their chaotic tumble through the dark. Its subsurface ocean, if it exists, continues its cold, lightless circulation, indifferent to whether we call it a planet or a dwarf or a Kuiper Belt object or anything else at all. Pluto was here long before us. It will be here long after us. Its 248-year orbit means it completes fewer than 20 revolutions around the Sun in the entire span of recorded human history. It is patient in a way that defies human comprehension. While civilizations rose and fell on Earth, while our species spread across the globe and developed language and agriculture and science and art, and sent tiny metal machines screaming away from home at 50,000 miles per hour, Pluto continued its slow, cold dance, unchanged. It doesn't need our validation. The story of Pluto is, in a way, the story of science itself. The process of replacing comfortable assumptions with uncomfortable truths. We assumed Pluto was simple. It isn't. We assumed it was dead. It isn't. We assumed the edge of the solar system was featureless. It is not. Every time we have looked more carefully at the things we thought we understood, we have found them stranger and richer and more complex than we imagined. That pattern has never failed. Not once in the history of science. Every world we have visited, every rock we have analyzed, every atmospheric spectrum we have measured has turned out to be more interesting than the model we started with. The universe does not simplify as you understand it better. It deepens. It opens into more questions than it closes. Pluto is a world of red snow, floating mountains, underground oceans, and a beating, freezing heart. It is a world that defies expectation at every turn. It is a world that, in its frozen, silent way, demands to be taken seriously. We may have taken away its title. We may have called it a dwarf. But Pluto remains a king in his own right, the undisputed ruler of the Kuiper Belt, lord of a domain that stretches from Neptune's orbit to the very edge of the Sun's gravitational reach, a region containing billions of icy worlds that we have barely begun to explore. It doesn't need our validation. It will still be there, continuing its silent dance in the dark, long after our own sun begins to expand, long after Earth's oceans boil away, long after the last trace of human civilization has been erased from the cosmos. Pluto will still be there, still orbiting, still cold, still breathing, still dreaming in whatever way frozen worlds can dream. But as isolated and mysterious as Pluto is, its silence is a mercy. Because if you leave the Kuiper Belt and travel backwards, moving just a little closer to the Sun, past Neptune, past Uranus, the silence disappears. It is replaced by a deafening roar, the shriek of chemistry run wild, the sound of a world that has taken everything physics allows and done something deeply, profoundly wrong with it. You will find a giant blue monster where the winds scream at 2,000 kilometers per hour, faster than the speed of sound on Earth, tearing the atmosphere apart in continuous supersonic hurricanes that have not stopped for centuries. Where the pressure in the deep atmosphere climbs to levels that would crush a submarine, where the temperature paradoxically is thousands of degrees in the upper layers, and where the rain is not water, it is not acid, it is diamonds, solid diamonds falling through a methane sky, dissolving in an ocean of liquid diamond deeper than the Earth is wide. But that is a story for another time. Pluto is enough for today. More than enough. Keep looking up. Stay curious. I hope you enjoyed the video. If you did, please consider hitting that like button. It genuinely helps this channel more than you know, and it helps get this content in front of more people who love the strange, beautiful, terrifying truth about the universe we live in. If you want more deep dives into the science of the cosmos, the places that would kill you, the places that shouldn't exist, the mysteries that keep planetary scientists awake at 3 a.m., then subscribe. New content every week. The universe is weird. We're going to explore all of it.